Now, hmm? Okay. Good day, viewers all over the world. Welcome to Toidel online class. Today, we want to discuss partial, partial fractions, partial fractions. So, we want to discuss partial fractions. Of course, from the word fractions, we are familiar with this. For instance, if you have a circle, this circle can be divided into two equal halves, like orange. If you can cut it into two equal halves, so it will be splitted into two. We can go ahead and cut it into four. So each of these will be one quarter, one quarter, one quarter, one quarter. So if we want to get that circle or that orange again, we have to merge everything together. So one quarter in four places will now give us one. So the concept of fraction has been introduced to us right from our elementary school. Now, partial fraction. Let's say given, if we are given 17, 7x plus 19 all over x plus 1 into bracket x plus 5, and this can be splitted into 3 all over x plus 1 then plus 4 all over x plus 5. Let's say we are given what we have on the board. What we have at this left hand side is called the compound fraction. That is the compound fraction. So this compound fraction can be decomposed to two partial fractions, to two different partial fractions. Then from the topic partial fraction, so the partial fraction of any compound fraction will be determined by the nature of the factors at the denominator. So under partial fraction, we are not that concerned with the numerator. But if you want to break a compound fraction into into some of its partial fraction, we concentrate on the denominator, like what we have here. This denominator has two factors. So if you want to break this down from here to this other side, then we will know that this is one factor, this is another factor. We are going to have two factors here. We split it into two factors. So whenever you want to resolve a compound fraction into some of its partial fractions, we look at the denominator. Not only that, in this case now, look at this numerator like this given example here. The degree of x at the numerator is just one. But if you expand what you have at the denominator, x times x, that's x square. That simply means that the power of x at the numerator is one all over x square. That will be the highest power at the denominator. That's half. So in this case now, this is a form of proper fraction. I'm talking about the degree. The degree of the power is a form of proper fraction. So under partial fraction, there are four different types that we are going to talk about. But each of these types of partial fractions that we have the same resolution. So how do we, when we have a compound fraction and we decide to resolve it to partial fraction, how do we now resolve it? How do we find the value? So there are two methods of resolution for us to be able to approach partial fraction. Methods of resolution, irrespective of the nature of that partial fraction. If you want to solve it, there are two methods that we use called method of resolution. The first one is cover up. The first one is cover up method. I'm going to show us this. And the second one is method method of comparing coefficients. Coefficients. What I'm trying to say in essence is that if you have a compound fraction and you have resolved that compound fraction into partial fractions, so how do we now solve the partial fraction? There are two methods involved, irrespective of the nature of that partial fraction. The first method of resolution is called the cover-up method, while the second method of resolution is called the method of comparing coefficients. So I'm going to use what I have on the board as example. Let's use that as example before we now break partial fraction into the types that we have. Let's say example. Say example. Example. Let's see this example. Example, we say resolve. Resolve what you have here, this compound fraction, into into partial into partial fraction. We want to resolve this into partial fraction. So if we are to resolve this, this is what we are given. We are given 7x plus 19 all over x plus 1 into bracket x plus 5. If you are to resolve this into sum of its partial fraction, this is what we consider. We concentrate on the denominator. In this case now, there are two factors here. There are two factors here. We have two different factors here. Then if you want to resolve this, just say we can use any coefficient and we can use any letters of the alphabet to represent the numerator. We just say, let's say a all over the first one, x plus 1, plus b all over x plus 5. That is what we have. So if that is what we have, then what do? I will now multiply both the left hand side and the right hand side by the denominator of the right hand side. That is, if I say x plus 1 multiply by x plus 5, this is equivalence. This can take care, what I have here can take care of everything here. So I'm going to have 7x plus 19 being equal to this one. No, we said this equivalence being equal to, if I bring everything here, if I use x plus 1 times x plus 5 to multiply this, I'm going to have a, I will have x plus 5 left. Then plus b. If I use everything that this denominator, if I use to multiply what I have here, I'm going to have x plus 1. And this is what I'm talking about. So if we are able to resolve everything on a straight line like I have it here, how do I get this? I multiply both the left hand side and the right hand side by the denominator of the compound fraction. So if I multiply through, this is what I will get. So once I get to this point now, then from this point now, there are two methods that I can use to get the value of a and b. The first method is what we call the cover-up method. So I'm going to use the two methods now so that we'll be familiar with the method of resolution of any given partial fraction. So let me start with the first one. The first one is called the cover-up method. The cover-up method. So how do we apply the cover-up method? Please, let's look at this. Look at what do we have beside a? Is it not x plus 5? And what do we have beside b? X plus 1. Then under cover-up method, this is what we do. We want to cover one so that we can get the value of the first variable. Then we come back and cover the second one and get this value. So look at, in this case now, if I want to use cover-up method now. If I say put x is equal to minus 5, I have x plus 5 here. Once I assume x to be minus 5, minus 5 plus 5 will be 0. Then this a will vanish. We'll be able to get the value of b. And that is the idea about cover-up method. Let me go over it again. Since we've been able to resolve this into a straight line, then there are two methods of resolution that we can do. The first one is the cover-up method, while the second one is the method of comparing coefficients. That's the second one. The second one is the method of comparing coefficients. So I decided to start with the first method of resolution. In this case now, under cover-up method, just think of the value of x. What will be the value of x here that will make this one that will make this part to vanish? Then in this case now we have x plus 5. So if I assume x to be minus 1, then minus 1 plus 1 and minus 1 plus 5 will be 0. So 0 times a, everything vanish here. Then I'll substitute the value to other. So I'm going to have, in this case now, I will now say 7 into bracket x here now is now minus 5 plus 19 is equal to, of course, if I say a into bracket minus 5 plus 5, this one will vanish. So I don't need to write it, but let me just put it there. Then b into bracket minus 5 plus 1. So 7 times minus 5 is minus 35 plus 19 is equal to, here I'm going to get 0 plus, then minus 4, minus 5 plus 1 is minus 12, minus 4b. So here I'm going to have minus 16 to be equal to minus 4b. Let's divide through by minus 4, minus 4. This will take care of this. Therefore, b will be equal to 4. So we have been able to eliminate a and we have gotten the value of b. So we also look at it again. Look at the second one. We have been able to eliminate this. We have gotten the value of b. Now you now said also put x to be equal to minus 1. Look at, if I want this b to vanish, once I assume x to be -1. -1 plus 1 will be 0. So everything all what I have here will vanish. I'll be able to get the value of a. Then once I put x equal to -1, then I'm going to have 7 into bracket -1 plus 19 to be equal to a into bracket -1 plus 5, then plus b into bracket -1 plus 1. So from there, what do we have? We are going to have 19 minus 7 to be equal to -4a. This will be plus 0. 19 minus 7 is 12, right? Then 12 will not be equal to, no, -1 plus 4, that's 4a, will not be equal to 4a. Divide both side by 4. At the end of the day, we'll get the value of a. Therefore, a is equal to 3. So we have been able to find the value of a to be 3 and b to be 4. So we'll now write out what we are given. We'll now say hence the compound fraction that we are given, 7x plus 19 all over x minus 1, x plus 1 into bracket x plus 5, has been resolved to, the first one is a. That will be 3 all over x and this is what we are asked to do. So in that given example, I've been able to use the method of resolution, the first one, which is called cover-up method, to get this value. So I want to use the second method of resolution, which is called comparing coefficients, and let's see if we are going to get the same answer. So the second method is the comparing coefficients method of comparing coefficients, or what have you. So in this case now, still the same thing. From that equation star that I gave the other time, that is from here, where we have 77x plus 19 being equal to a into bracket x plus 5 plus b into bracket x plus 1. This is where we started from when I applied the first method. So what do we do here? We are going to open up here. We open everything up here. We are going to have ax plus 5a plus bx plus b. So we are going to bring everything together. I know this as we can combine. We have a plus b into bracket x, then constant plus 5a plus b. This is what we have. Then from here, we have 7x plus 19. That is what we are going to get. So what do we want to compare here? What is the coefficient of, look at the coefficient of x here. Is it not a plus b? What is the coefficient of x here? 7. We now say a plus b is equal to 7. Equation 1. Let's look at the constant. We have 5a plus b here. We have 5a plus b. What is the value of constant here? 19, equal to 19, equation 2. So this is how to approach this method of comparing coefficients. So we at this point now, we have been able to compare the coefficients here. We equate the coefficient of s squared to coefficient of s squared at the left-hand side. Then the constant, we equate it to the constant at the left-hand side. So there are two equations here. We can solve it simultaneously. So I'll say equation 2 minus equation 1. So 5a minus a, that is 4a. B minus b, we cancel out. 19 minus 7, that is 12. Divide both sides by 4. And then we are able to get a to be equal to 3. Okay? Then since we have gotten the value of a to be equal to 3, we can go ahead and substitute. A is equal to 3 into any of the two equations. That is, we can say substitute a is equal to 3 into equation 1. What is equation 1? A plus b is equal to 7. So 3 plus b is equal to 7. Then b is equal to 7 minus 3. So b is equal to 4. And that is what we also have when we use cover-up method. So hence 7x plus 19 all over x plus 1 into bracket x plus 2 is equal to 3 all over x plus 1 plus 4 all over x plus 5. So from what we have done now, we have been able to realize that whenever we want to resolve any form of partial fraction, there are two methods involved. The first one is method of comparing coefficients and cover-up method. Then the second one is method of comparing coefficients. But in some questions, in some problems, we can actually apply the two, depending on the nature of our resolution. So that is how to resolve any given partial fraction. So I will move into types of partial fraction. Types of partial fraction. Basically, we have four types of partial fraction. We have four types. So I will try and itemize them, and I will take each one after the other. We have four types of partial fraction. There are four types of partial fraction, but from this introduction, I said if you want to resolve any given partial fraction, we are expected to concentrate at the denominator. It is the nature of the denominator of the compound fraction that will determine what we are going to do. So the first one that we have, there are four. The first one, talking about the nature of the denominator of that compound fraction. The first one is unrepeated, unrepeated linear, unrepeated linear factors. Like the example that I gave, that example, the first example that we considered, the nature of the denominator is unrepeated. It's not the same thing. You know, one is x plus 1, the other one is x plus 5. So, and they are linear. Linear in the sense that their degree, their power is x power 1. So, they are linear. It's different from you getting x squared plus 3. That one is quadratic. So, the first type of partial fraction that we have is unrepeated linear factors. So, like this first one now, this first example, this first type is the example that I gave. So, we have been able to consider this. We have considered example under this. Then the second type of partial fraction is repeated factors. Repeated, repeated factors. That is when we have something like in form of square. Repeated factors, either linear or non-linear. So this is the second type. Whenever you are asked to resolve a particular compound fraction into some of its partial fractions, concentrate on the denominator. It is the nature of that denominator that will determine what to do. So the second one is repeated factors, either linear or non-linear. Then the third one is non-linear. When we have non-linear factors, non-linear factors that are not repeated, that are not repeated. So I will try and give one example each. Then the last one is when we have improper. When we have improper fraction. So I will give one example each on this. I'm going to give one example each. So look at the four types of partial fraction that we have. The first one is when we have unrepeated linear factors. And I said the example, the example that I gave, the first example is the example of these unrepeated linear factors. The second one is when we have repeated factors that is either linear or non-linear. I'm going to give example on this. The third one is non-linear factors that are not repeated. I'll give one example on this. Then the last one is when we have improper fractions. So we are going to take one example each on this type of partial fractions. So at least we have been able to establish that there are four types of partial fractions. So the first one now, that first one, unrepeated linear factors, is the example I gave. This example, 7x plus 19 all over x plus 1 into bracket x plus 5. So let's concentrate on the denominator. In this case now, and let me say this, the first three types, they are in form of proper fraction. Proper fraction in the sense that the degree of x at the numerator is less than the degree of x at the denominator. For instance, this is what I'm saying. What is the highest degree of x here? It's not x raised by 1. If I expand this now, I'm going to get what? X raised by 2. So 1, 2, half. That is proper. The first three types of partial fraction are example under proper partial fraction. Then the last one, which is improper, that is what we concentrate on. So we have been able to give example on the first one. I've given an example on the first one. Okay, let me give another example. Let's say example 2. On type 1, let's say type 1. We are still under type 1. Type 1. Type 1, example. Example, let's say example 2. I say resolve 2x squared plus 3x minus 1 all over x into x squared plus 4 minus 4 into partial fraction. We have to resolve this into partial fraction. Of course, if you look at this now, solution, look at the degree of x. The highest degree of x at the numerator is 2. But if I use x to multiply x squared, I'm going to get x cubed. So you realize that it is 2 over 3. This is improper. I'm talking about the degree of x. So in this case now, this is what you are given. 2x squared plus 3x minus 1 all over x is one factor on its own. Then we also have x squared minus 4. That's another factor. Then I can rewrite this denominator, because this denominator, I can rewrite this. There's what we call difference of 2 square. For instance, where I have x squared minus 4, I can break this down to x squared minus 2 squared. Then when we have difference of 2 squared, it's same thing as you saying x plus 2 into bracket x minus 2. So I'm going to change this x squared minus 4 to x plus 2 and multiply by x minus 2. So here I'm going to have 2x squared plus 3x minus 1 all over x into x plus 1, x into x plus 2, x minus 2. And this is what we are going to have. If you look at this now, if you look at this denominator, we have unrepeated linear factors. The factors are not repeated. So in this case now, if I want to resolve this into partial fraction, I can say a all over the first factor, x, plus b all over the second factor, x plus 2, then plus c all over x minus 2. That is how I'm going to resolve this into partial fraction. Then from there, I'm going to multiply everything. I will multiply everything by the denominator. So if I use this right hand side down, this will represent the given question. I've been able to resolve this. So this will represent what I'm going to do now, the right hand side. So if I use x into x plus 2 into x minus 2 to multiply this is what I'm going to have. I'm going to have 2x squared plus 3x minus 1 being equal to, look at, if I use the whole of this to multiply what I have here, I'm going to have a into bracket a into a multiplied by x into bracket x plus 2, x minus 2, plus b. If I use everything here to multiply here, this will take care of this. I will have x into x minus 2. Then plus c. This to multiply this, I will be left with this. I will have c into bracket x into x plus 2. And that's what I'm going to have. So this is the straight line that we want to resolve now. Of course, I can use cover-up method here, and it will be faster. So I will say put x equal to 0. That is when I have this x. Once I put x equal to 0, this will cancel out. Everything here will cancel out. If I put, no, in this case now, there won't be x here. I'm going to have a, because if this will multiply this will cancel this. I'm going to have, so if I put x equal to 0, what will happen? Just substitute 2 into bracket 0 squared plus 3 into bracket 0 minus 1 is equal to a into bracket 0 plus 2, 0 minus 2 plus b. Once I do that, once I substitute x to be 0 here, everything here will be 0. If I substitute x to be 0 here, everything will be here will be 0. Then at the end of the day, here will be 0, 0, 0, 0. We are going to have minus 1 being equal to 0 plus 2. This is 2. Minus 2. Minus 2 times 2, that's minus 4. Minus 4a. Then if I divide both sides, if I divide both sides by minus 4, so a will now be equal to 1 all over 4. And that is what I'm going to get. So the value of a will be 1 raised to power 4. So I've been able to find 1 out of the 3 unknown. Then I also say put the second one s equal to 2. I'm going to have 2 into bracket minus 1 to be equal to, when I put s equal to 2 here, no, this will be 2 minus 2. 2 minus 2 is 0. Everything here will vanish. Our f is equal to 0 plus, if I put s equal to 2 here, 2 minus 2 is 0. Every here will be 4. 4 times 2, 8. I'm going to have 8c. Then 2 times 2, 4. 4 times 2, 8. I'm going to have 8 plus 3 times 2, 6. Minus 1 is equal to 8c. Then this is 13. 13 is equal to 8c. Divide both sides by 8. Therefore, c is equal to 13 all over 8. So I've been able to get the value of a and the value of c. Then the last one is when I put x is equal to minus 2. I'm using the cover up method now. So when x is equal to minus 2 squared plus 3 into bracket minus 2 minus 1, so it being equal to b. Then 1 is equal to 8b. So divide both sides by 8. So b is equal to 1 all over 8. So when I apply the method of resolution, when I applied cover up method here, we have been able to get the value of a. Therefore, our a is given as what? We have been able to get the value of a to be 1 all over 4. We have b to be equal to 1 all over 8, and c to be equal to 13 all over 8. So I will now go back to what we are given. I'll go back to what we are given. That is 2x squared plus 3x minus 1 all over x into x squared minus all over x, plus the second one is b to bracket x minus 2. And that is what we are going to get. So that is what we are going to get. So we have been able to resolve this compact fraction now into some of its. So I'll go to type 2, and I'll give just one example under type 2. This type 2 is when you have repeated factors with either linear or non-linear. So let's say example, say example 3, say resolve 2x plus 3 all over x squared into x plus 3 squared into partial fraction. Let's look at this. In this case now, of course, as I've said earlier on, if you want to resolve any compound fraction into partial fraction, you concentrate on the denominator. Look at this now. We have repeated factors. This is x squared, that is x and another x. We also have x plus 3 all squared. They are linear. So the question is either they are linear or non-linear. But in this example now, we realize that we are given linear factors. Of course, so how do we resolve this? How do we resolve this into partial fraction? Let me state it here. We have 2x plus 3 all over x squared plus x squared into brackets x plus 3 all squared. By the time we want to resolve this, this is what will happen. You say a all over, you first write x plus, we now say b all over, write the repeated one. If you have x cubed, we are going to have a all over x plus b all over x cubed plus c all over x cubed. If it is squat, s in 4 places, we'll break it down. We start from 1, 2, 3, 4. But in this case, we have s squared, so this is how we resolve it. Plus c, we go to s plus 1, s plus 3, then plus d all over s plus 3 squared. So under type 2, which is repeated factors, either linear or non-linear, this is how we resolve it. Then if that is taken, then we can go ahead and do the needful. From here now, multiply everything through by the denominator, by the factors that we have at the denominator. If we do that, we'll be left with 2x plus 3 at the left hand side. Then s can take care of 1x. I'll be left with x a into x plus 3 all squared plus s squared will take care of s squared. We'll be left with this. We have b into x plus 3 all squared plus s plus 3 we cancel one of these. Then we have C, S squared into X plus 3. Then plus D, S plus 3 squared, we cancel S plus D, S squared. And that is what we have. So at this point now, we can use two methods here. We can use either method of resolution, and we can use the two method of resolution. So we can start with the cover-up method. So once we use the cover-up method, some things we cancel out. Once we use the cover-up method, some things we cancel out. We'll be able to get the value of, let's say, put X. Since we have X here, I can say put S equal to 0. If S equal to 0 here, what will happen? We have 2 into bracket 0 plus 3 is equal to, once S equal to 0 here, everything here will vanish. I'm going to have 0 plus, but here we have something here. If S equal to 0 here, what will happen? I'm going to get, if S equal to 0 here, I will have is 0 plus 3, that is 3. 3 squared, that is 9. 9 times B, I'm going to have 9B plus, if I put S equal to 0 here, everything here will vanish. 0 plus, this one will also be 0. At the end of the day, 2 times 0 is 0. I'm going to have 3 to be equal to 9B. If I divide both sides by 3, if I divide both sides by 9, 9 will take care of 9. Therefore, B will now be equal to 1 all over 3, because that's 3 all over 9. We have gotten the value of B. We have gotten the value of B. Then I can also say put S is equal to, I have plus 3 here, minus 3. If I do that, I'll get another value. That is, from there now, I will say 2 into bracket minus 3 plus 3 is equal to, let's look at, if S is equal to minus 3, if I put minus 3 here, minus 3 plus 3 is 0. Everything here will vanish. Plus, everything here will also vanish. Plus, everything here will vanish. Plus, minus 3 square, that is 3, minus 3 times minus 3, that's 9. I'm going to have 9D here. Then 2 times minus 3, that's minus 6 plus 3. Minus 3 will now be equal to 9D. Divide both sides by 9. 9 will cancel 9. Therefore, D will be equal to minus 1 all over 3. So we have been able to get the value of B and D. We are left with A and C. So we are left with A and C. So what do? We can use cover-up method or true. We can use cover-up method or true. And if you don't want to use cover-up method, we can just open up, you compare coefficients. We can also do it that way. If you don't want to use my method now, this cover-up method that I decided to use, just open up everything. So if you have something like S square here, and there's no S square at this place, just say 0 is equal to this. That's what you do. So we have been able to get the value of B and D. So we can now assume, we can put S to be a neutral, put S to be equal to, let's say 1, the neutral value. So if we put S equal to neutral value, we are going to get value for A, B, C, D. Then I will say 2 into bracket 1 plus 3 is equal to A. This is 1 into bracket 1 plus 3 all squared. 1 plus 3 all squared. 1 plus 3 all squared. Then plus B into bracket 1 plus 3 all squared plus C multiplied by 1 into bracket 1 plus 3 plus D into bracket 1 squared. So from there now, we are going to have 2 times 1, that we are going to have 5 to be equal to 1 plus 3 is 4, 4 squared, 16A, that will be 16A, plus 1 plus 3, 4 squared, 16B, plus 1 plus 3, that's 4C, then plus D. That is what we are going to get. So that's what we are going to have. But we know B. We know B to be equal to, B is given as 1 over 3. We have gotten that value. And we know D to be equal to minus 1 over 3. So let's substitute. I will have 5 to be equal to 16A plus 16 all over 3. When I substitute, plus 4C minus 1 all over 3. So from there now, from this point, we can multiply through. We can multiply through by 3. This is all over 1. So we can say the LCM here is 3. Here will give you 48A plus 16 plus 16 plus 12c minus 3 in 3 in 3, 1 minus 1. So equal to 5. If I cross multiply, I'm going to get 48a plus 12c plus 15 to be equal to 15. That's what you're going to get. Then I will have 48a plus 12c to be equal to 15 minus 15. So from there, I'm going to get 48a plus 12c to be equal to 0. I can call that one equation 1. I can call it equation 1. So we can also assume, we can also put x is equal to minus 1. Then if you do that, we now substitute it back to that equation star. Then if you substitute back, we are going to have 2 into bracket minus 1 plus 3 to be equal to, if you substitute that into the given equation, that star equation star that we have the equation there, equation star. If we substitute that correctly into that equation star, then this is what we have. We are going to have a multiplied by minus 1 into bracket minus 1 plus 3 all squared plus b into minus 1 plus 3 all squared plus c multiplied by minus 1 squared into bracket minus 1 plus 3, then plus d minus 1 squared. So if we now open up, this is minus 2 plus 3 being equal to 3 minus 1, that's 2. 2 times 2, 4. We are going to have minus 4a. We are going to get minus 4a here plus 4b. Then here, this is 2 plus 2c. We are going to have this to be 2c, then plus d. That's what we are going to get. So if you substitute for b, when b is equal to, we know that b is equal to 1 all over 3 and d is equal to minus 1 all over 3. If we substitute the value there, we are going to get 3, we are going to get 1 here being equal to minus 4a, where we substitute plus 4 all over 3 for b, then plus 2c minus 1 all over 3. Let's find the LCM of the left hand side. This is 3. I'm going to have minus 12a plus 4 plus 6c minus 1 equal to 1. When you cross multiply, I will have minus 12a here plus 6c plus 3 equal to 3. So I will have minus 12a plus 6c being equal to 3 minus 3. So I will have minus 12a plus 6c equal to 0. Equation 2. So when we bring equation 1, let's bring the two equations together now. We can bring the two equations together. The first equation that we got, that's the equation 1, is 48a. 48a plus 12c equal to 0. Equation 1. So there are two equations here. We can solve the two equations simultaneously in order to get the value of a and c. So I can say 2. From here now, I can say let 2 multiply equation 2. If 2 should multiply equation 2, I'm going to get minus 24a plus 12c equal to 0. Equation 3. Then if we had, let's say, equation 1 minus equation 3, that would be 72a. 12c minus 12 is 0. Is equal to 0. So a is equal to 0. That's what we get. So if a is equal to 0, let's go ahead and substitute. Let's go ahead and substitute the value for a. I will say 48a plus 12c equal to 0. If a equal to 0 here, I will have 48 into bracket 0 plus 12c equal to 0. Then 12c equal to 0, c is equal to 0. So therefore, we have the value of a to be equal to 0, b to be equal to 1 over 3, c to be equal to 0, and d to be equal to minus 1 over 3. So the final answer, 2x plus 3 all over s squared into s plus 3 squared will now be equal to a is 0 all over x plus 1 all over 3 over s squared plus is 0, which is c, all over s plus 3, then plus plus minus 1 all over 3 all over s plus 3 all squared. So if I write this, of course, this will be 0. Here will be 0. This will be 0. I will just have 1 all over 3s squared minus 1 all over 3 into bracket s plus 3 all squared. And that will be the resolution. So that will be the final answer that we have under the given example. So if you look at this example 3, example under the type 2, I decided to use the cover-up method as the method of resolution. So I want you to try the method of comparing coefficients. At the end of the day, we get the same answer because it seems the method of comparing coefficients is simpler. It's simpler and it's easier. So I decided to use cover-up method here. So I want you to use the method of comparing coefficients. We must get the same answer at the end of the day. So I will now go to type 3. The type 3. This type 3 is when we have nonlinear. Type 3 is when we have nonlinear factors that are not repeated. Nonlinear factors that are not repeated. Okay? Nonlinear. If a factor is not nonlinear, if it's nonlinear, it could be quadratic, it can be trinomial, it can be s squared, s cubed, but they are not repeated. Let's say example 4. Example 4. I'll say resolve. This example under type 3. Resolve 10s squared plus x plus 9 all over x into 2x squared plus 3 into partial fraction. So into partial fraction. So if you look at this now, you realize that we can solve this. What I have in this bracket at the denominator, 2s squared plus 3. This one is not linear. Is quadratic. Is s raised power 2. And these factors that I have here, you cannot break it down into 2 different factors. So it is non-linear. So how do we resolve this into partial fraction? That is what we are about to do now. This is what you do. This is what we do. Solution. If you have this type of problem under partial fraction, this is how to resolve it. Let's concentrate. Of course, this first one is x. You just say a all over x plus, because we have s squared here, presence of s squared here, and we can't break it down into 2 factors, then the numerator now will now attract. So if you want to resolve this now, because we still have s squared here that we cannot break down, we can now write bx plus c here all over 2s squared plus 3. Please, let's look at this. This is s squared. Of course, at the bin, we can break this s squared into 2 factors because it is not linear. It's not linear. If it is linear, we can break it down. But now that it's not linear, we can't break it down. We can't factorize this. Then the method of resolution will attract 2 constants at the numerator with the presence of 1. If what you have here is s cubed and we can't break it down, I'm going to have, if you want to resolve this, it will be bs squared plus cs then plus d. That is what we are going to have. So we cannot break this down. We can't break it down. That is what we are going to have. Then, if we multiply everything by the denominator of the left-hand side, I'm going to have 10x squared plus x plus 9 being equal to a into bracket. S can take care of x. I'll be left with 2x squared plus 3. Then plus bx plus c. That's what we have now. Into bracket, this can take care of this. We have only x here. Okay. Then here, okay, in type 2, I try to use cover-up method. Now let me use using comparing coefficient. Let me use comparing coefficient here. So that comparing coefficient, I want to be using the 2 methods interchangeably. I'm going to have 10s squared plus x plus 9 being equal to 2as squared plus 3a plus, if I open up here, I will have bx squared plus cx. Then let me collect the like terms here. I will have 2a plus b, everything s squared when I combine these two, then plus cx plus 3a. 1, 2, 3, 4. And that's what we are going to get. Then From there, if I compare the coefficients now, let's compare the coefficients. What is the coefficient of x squared at the right hand side? It is 2a plus b, and is equal to, what's the coefficient of x squared at the left hand side? It is 10. You can call that equation 1. Let's go to x. What's the coefficient of x here? Is c, and it's equal to, here the coefficient of x is 1, c is equal to 1. Then the third one, the constant here is 3a, and at the left hand side here is 9. So we can divide both sides by 3, so that a is equal to 3. So a is equal to 3. We have gotten the value of a, we have gotten the value of c. So then we know this equation. So we can substitute a is equal to 3 into equation 1. I have 2a plus b is equal to 10. So here I'm going to have 2 into bracket 3 plus b is equal to 10. 2 times 3 is 6. So b is equal to 10 minus c. B is equal to 4. So we have been able to find the value of a, b, c. So therefore, a is equal to 3, b is equal to 4, and c is equal to 1. Hence, we can write the partial fraction now. We now say hence 10x squared plus x plus 9 all over x into 2x squared plus 3 will now be equal to, what is a? A is 3. 3 all over x plus b is 4. That is 4x plus 1 all over 2x squared plus 3. And that is what we are going to have. So we have been able to resolve this compound fraction into some of its partial fraction. So you can have so many examples. Just go through standard textbooks. You can have so many examples on this, but I decided to give one example each. And if you come across anyone that you think is difficult, you can just put it at the comment section. I promise to handle that for you. Then let me go to the last one, type D. The type D. No, type 1, type 2, this one will be type 4. That is where we have improper fractions, compound fraction that involves improper fraction. So what are we expected to do there? Let me give example 5. Example 5, where we have resolve s cubed minus 1 all over s squared minus 4 into partial fraction. So I want us to check the type 1, type 2, type 3, the first 3 types of partial fraction that we have discussed. You will realize that when you open up the power, the coefficient, the power of s cubed, the degree of s cubed at the numerator is less than the degree of s cubed at the denominator. Look at this. This is s squared. If you say x times 2s squared, that will be 2s cubed. S squared at the numerator, cube at the denominator. Check the 4 different examples that we have considered. You realize that they are in proper form. But in this case now, like this type 4, the example 5, the degree of x at the denominator is greater than the denominator. So in this case now, it's 3 over 2 is improper fraction. So when we have partial fractions that involve improper fractions, how do we resolve this? We cannot do this directly. What we are expected to do is to first divide this using the long division method. When we consider polynomials under division of polynomial, the knowledge is required here. So what am I expected to do here? This is what I will do. I will put s cubed minus 1 in, then I will divide it by s squared minus 4. So you will not think, what will I use to multiply s squared to get s cubed? That is x. So x times s squared, that is s cubed minus 4x. You introduce minus, this will be plus, this will cancel out. So I'm going to have 4x minus 1 as the remainder, because s squared cannot divide 4x. So this is what you are going to have. Then, if you are able to do this now, we can now resolve it. We cannot resolve this directly. We first use long division method to get what we have on the board. Before we do the resolution, we now say s cubed minus 1 all over s squared minus 4 is equal to your divisor and your result, your quotient x plus remainder 4x minus 1 all over divisor s squared minus 4. That is, if you have partial fractions that involves improper fraction, you say it is quotient plus remainder all over divisor. That is what you are going to get. So this example 5, you cannot resolve it directly because the degree of x at the numerator is greater than the one at the denominator. So you first use long division method to resolve this. Then if you're able to resolve this in this form, then you can go ahead and look for, we now resolve this into partial fraction before we now write out the final answer. So we now say, then, then we will resolve, we now resolve, then then we now resolve 4x minus 1 all over x squared minus 4 into partial fraction. That is, when I have 4x minus 1 all over x squared minus 4, is same thing as 4x minus 1 all over, this is difference of 2 square. Here is difference of 2 square. I can change it to s plus 1, s plus 2 into bracket x minus 2. This is difference of 2 square. We can change 4 to 2 square. So s square minus 2 square, that will be x minus s plus 2 and s minus 2. So if I resolve this, these are linear, that are non-repeated. Type 1, that will be a all over x plus 2 plus b all over x minus 2. So if I multiply through by s plus 2, s minus 2, I'm going to have 4x minus 1 to be equal to a into bracket x minus 2 plus b into bracket x plus 2. So this is what we have. So from there now, I will go ahead and use the method of cover-up method. Put s is equal to 2. If s is equal to 2 here, I'm going to have 2 into 4 into bracket 2 minus 1 to be equal to, when I put s equal to 2 here, 2 minus 2 is 0. Here will be 0 plus 2 plus 2, 4b. I'm going to have 4b there. So 4 times 2, I'm going to have 7 is equal to 4b. If 7 is equal to 4b, I still want to hold on. If 7 is equal to 4b, then b is equal to 7 all over 4. Then we also say put s is equal to minus 2. If s is equal to minus 2, I'm going to have 4 into bracket minus 2 minus 1 to be equal to, if I put s equal to minus 2 here, I'm going to have minus 4a, minus 2 plus 2, this one will vanish, plus 0. This will give me minus 9 to be equal to minus 4a. Then minus 9 is equal to minus 4a. From there, what do we get? A is equal to 9 all over 4. So a is equal to 9 all over 4 and b. So therefore, s cubed minus 1, which is equal to s squared minus 4, that we have resolved here, will now be x, this s, plus, this is what we resolved in the partial fraction to get a and b. Let me first write out what we resolved. That is 4x minus 1 all over s squared minus 4 is now equal to a. A is 9 all over 4 into bracket 9 all over 4 into bracket x minus 2, 9 all over 4 into x plus 2, plus b, which is 7 all over 4 into bracket x minus 2. We can write this. So this one, we can rewrite this. What we have here, we can rewrite it from here now. We can rewrite this. We can write it to be 9 all over 4 x plus 2 plus 7 all over 4 into x minus 2. That's what we get. So 4x minus 1 all over x squared minus 4. 4x minus 1 all over x squared minus 4 is equal to this. Finally, this is what we are given. S cubed minus 1 all over x squared minus 4 will now be equal to, we first write this one, x plus, what is the relation of everything here? You just put the value here. 9 all over 4 into bracket x plus 2 plus 7 all over 4 into bracket x minus 2. And that is be the final answer. So we have been able to resolve this into sum of its partial fraction. So far, we have been able to consider all the 4 types of partial fraction. We have been able to consider all the 4 types of partial fraction. The first one, the second, the third, and the fourth. So if you have any question that you are unable to solve, just type it in at the comment section. I promise to attend to it and to be of assistance. So we in the summary of everything that we have discussed today is that if you want to resolve a partial fraction, there are two methods of resolution. The first one is cover up method, and the second one is comparing coefficient method. So you can use the two methods interchangeably, depending on the one you decide to use. Then we are also able to divide partial fractions into four types. The first one is when you have unrepeated linear factors. That's example 1 and 2. The second one is when you have repeated factors, linear or non-linear. That's example 3. Then the third one is when you have non-linear factors that are not repeated, example 4. And the fifth example that we consider is under improper fraction. So I'd love to stop here. If you have further question, just type it on the comment section. I promise to attend to it. Thank you.